In this lesson we're going to plot positions. So if we were given a latitude and longitude and we needed to plot that onto the paper chart, we're going to use the techniques to do that. So at 9 o'clock we were given a visual fix with a latitude and longitude. Typically the easiest thing to do is to go ahead and take that latitude and longitude and put a little hack mark at the appropriate latitude and longitude. So the latitude is 36 degrees, 54.9 minutes north, so 36, 50, 51, 52, 53, 54.9. So right here, this is our latitude line, 54.9 minutes north. So, and the whole thing would be 36 degrees, 54.9 minutes north. Longitude is 75 degrees, 34.6, so it's 30, 31, 32, 33, 34.6. So that would be the 34.6 minutes west. And then really what we're going to do is we're going to extend the hack marks, and wherever they intersect would be our 9 o'clock visual fix. So it's going to look something like this. Extend this latitude, then we're going to extend this longitude, and where they intersect would be the fix. And we're going to expect to see some kind of look like that. So again, where the latitude and longitude lines intersect would be our fix. Now we always want to kind of have an appreciation for the general area. So we're looking for an answer in this area about here. But we need to do it a little more accurate than these little scribe lines we have going here. So let's use our nautical instruments to plot it properly. So the first thing I'm going to do is let's work with the latitude first. Here is my latitude. I set my dividers at the appropriate latitude. Now as long as I'm parallel to a reference line, in this case a parallel of latitude reference line, I can transfer that latitude to a reference line right here, just like that. So these two hack marks are on the 54.9 minute north latitude. So I can go ahead and just scribe a line where I expect the longitude line to come up and intersect. So right now I'm using this right here as my latitude. And then all I need to do is take the longitude and come up and see where it intersects. Let's use the same type of method with our dividers. I'm using a reference line of longitude. The meridian of longitude is 75 degrees 40 minutes. So again, any place I am on that longitude, and you can see it intersects it right there. Now I could just use my dividers and do a little tick mark, a little crossing, just like that. And that's a very appropriate way to do it. So it's a visual fix, which means it's a circle. It's a fix, which means I label the time on the horizontal. So that's a 9 o'clock visual fix at the given latitude and longitude. Now going over to answer the questions. It says, what shape do I use? I use a circle. And again, circle stands for visual fix method. The depth, I see there's a 64. And I go down to the soundings of the chart. It says it's in feet, 64 feet. Perfect. Okay, the next one is a 10 o'clock GPS fix with a latitude and longitude. So the latitude is 36 degrees 53.7, so 50, 51, 52, 53.7, so 53.7 minutes north. And then a longitude is 75, 31.4, 75, 30, 31, and then 0.4. So this is 31.4 minutes west. So again, I just need to see where these two lines intersect. Let's try a different method this time. We used the dividers last time. Let's use the parallel rulers this time. So again, I'm looking for reference lines. So on this particular one, I'm going to use this here 75 degree 40-minute reference line and put one edge of the parallel rulers against that, and parallel to it I go over to my longitude to scribe a quick line there. You can see, so this line just got extended from here for my longitude. My latitude, let's just again use this technique. And I'm just finding a reference line that works for me that I could extend. So, and I'm using the bottom, and I go up to the latitude, and I go across, and I scribe my little line of position. So I get right here. Here's where they two intersect, and a GPS fix, any electronic fix, is done with a triangle. And the time was 10 o'clock, and since it's a fix, it's on the horizontal, so that's what it looks like. Triangle, 10 o'clock. Oh, so the shape is a triangle. And the bottom type. The bottom type is S space SH. So that stands for sand and shells. So that's the bottom type right there. Okay, for the next one, which is the estimated position at 11 o'clock, let's use a combination of the two systems we've used so far. So for my longitude is 75 degrees, 38.2. Let's do our hack marks. It's always a good idea. 35, 36, 37, 38.2 right here. So that's 38.2 minutes west. And I can set my dividers right now. Okay. And then for the latitude, let's use the parallel ruler method. So I line up a reference line. In this case, I'm using the 36 degree 50 minute parallel of latitude, and I go up to the 55 right here. All I have to do is lock in my longitude. Oh, and look at that. It falls right over the Yankee alpha buoy that we dealt with before in the previous exercises. So it's right on the dead center of that. And estimated position is always done with a square. So that's a square. Square. And the question asks what nav aid is in our square or at our estimated position, and that's the buoy Yankee Alpha. So there you have it, the 11 o'clock estimated position. Alright, the next basic skill we need to learn how to do is to take measure bearings and distances. So bearings are angular measurements, and distances are done on the latitude scale as typically nautical miles. And the first thing we're going to do is we're going to measure from the Chesapeake Light to the buoy Yankee Alpha. So here's the Chesapeake Light. We've dealt with this navigation aid before. I'll zoom in a little bit. And the second navigation aid that we're going to deal with is the Yankee Alpha, right here. Now I'm going to add, just for clarity, a couple of reference lines just so you can see it. The first reference line I'm going to add is going to be the bearing line that we're going to measure. So it's from Chesapeake Light through the buoy, just like that. The second reference line that I'm going to add, again, is just for clarity, is going to be the Meridian of Longitude that I'm going to use. And I got it right there, so you can now see those reference lines. And I'm measuring from the northern position, if you will, on the top of the reference line, clockwise to where it intersects the blue reference line, which is the bearing. So I will go ahead and show you what I'm talking about here. I'm lining up the south portion of the parallel rulers on my reference line, and then I'm sliding it up and also rotating it so that I bisect the two navigation aids that I'm trying to intersect, so it looks just like that. So I've got, again, the south mark is on the bottom of my reference line. That's the red line. And I'm going from Chesapeake Light to the Yankee Alpha buoy. So that is the direction of the bearing. And I read where the reference line intersects the graduated scale. So I have 70, 75, 76, 77, 78. So 78 degrees. 078 would be that bearing. 078. Bearing 078 degrees true is the bearing. And let me measure that distance. So I'm going from Chesapeake Light to the Yankee Alpha buoy. Kind of distance doesn't matter which way you go, but just easier to always work in the same direction as the question is asking. So here's 1 minute of latitude, which is 1 nautical mile, 2 nautical miles, 3 nautical miles, 3.5, 0.6, 0.7, 0.8. So 3.8 nautical miles. 3.8 nautical miles. Early. So this was 0, 1, 2, 3 nautical miles. So 1, 2, 3, 3.5, 6, 7, 8, 3.8 nautical miles. So 3.8 nautical miles. 3.8 nautical miles. Next question, Chesapeake Light to the buoy Yankee Charlie Delta India Papa 147. So that's this one right here. So let me zoom in on those two. Okay. I'll have the same reference line for the bearing. So I'll go back to my blue. Going from Chesapeake Light through the buoy, it'll look like that. Okay, now for this time I'm going to use the compass rose. Okay, and then I'm going to walk it over to the nearest compass rose. Now I'm going from the Chesapeake Light that way, so the northwest direction. So I'm going to go from the compass rose going to the northwest direction. I put a little flag or an arrow, and then I just need to read the outer ring, and I come up with 335 true. So 335 true. And for the distance on that between those two navigation aids, here to here, is 0.7 nautical miles. So 0.7 nautical miles. And there you have it. So we've measured bearings in two different ways. We've used the parallel rulers, the graduation of the parallel rulers, right like here. We've used the graduation of the parallel rulers, and we've also used the compass rose.